Okay, we want to graph a logarithmic function in its most basic form. That means it has not been translated. It does have a base of 1/2, so that's a little interesting, but not overwhelmingly interesting. Now the exponential function, we have y when we're graphing it, we call it y. Y is equal to some base to the x. And for the logarithmic function, we have the log base b of x is equal to y. This is the same thing as b to the y is equal to x. And if I interchange x and y, b to the x is equal to y. So this is the inverse. And the inverse happens by a reflection over the line y is equal to x. So if the exponential function looks like this, well, with a base less than 1, it looks like this. That always goes through the point 0, 1, unless it's been translated, which these have not been. These are basic, not translated. And 1b. And it always has y equals 0 as an asymptote. Then what happens for, this is for exponential, what happens for logarithmic is that I have x is equal to 0 as an asymptote, and I go through the point 1, 0, and I go through the point b, 1. So this has a vertical asymptote, not a horizontal asymptote, and it goes through the point 1, 0, and it goes through the point 1/2, 1. And so it looks like this. Now think about f of x is equal to 1/2 to the x. That goes through the point 1, 0, so 0, 1, and 1/2. 1. 1, 1/2. It looks like this with the horizontal asymptote. Okay. So if I reflect that over this line right here, instead of approaching the x-axis as x becomes very large, I'm going to approach the y-axis as x becomes closer to 0. So let's draw that over again. So 1/2 to the x looks like this. And if I transform it, so in this one right here, as x goes to infinity, y goes to 0 from above. In this one, as x goes to 0 from the right, y goes to infinity, positive infinity. So that arrow notation is useful for us as well here to check ourselves before we hit submit